Hello everyone. In today's class, we will go for discussing functional testing and functional testing techniques such as boundary value analysis and equivalence class partitioning. So here, first we will go for looking into what is functional testing and the concept of black box testing, white box testing, boundary value analysis technique and equivalence class partitioning technique, and how these techniques are useful for the generation of test cases. So functional testing techniques attempt to test every possible functionality of the software. So whatever the functionalities a software is having, so the main aim of this functional testing is we are going to ensure whether these functionalities of the software they are working properly or not. So test cases are designed on the basis of functionality, and the internal structure of the program is completely ignored. So here we are not concerned about what is happening inside the code. The main aim is we are going to ensure whether a particular functionality is working perfectly or not. So functional testing is a black box testing technique. So here we will see what is the black box testing technique. So whatever the testing methods or strategies we are using, broadly we can classify them into two categories. Some comes under white box testing methods and some comes under black box testing methods. So if you look at black box testing technique, here we consider the whole software as a black box. So black box in the sense what is happening inside that we are not concerned about, and we give input to the system. There may be some external events they may occur, and what the output my system is giving, the input and the according to the events, what my system is going to provide as output or the final result. And this is going for comparing with the requirements. So if it matches with the requirements, then we can say that my system is fine, or whatever functionality I am interested for, that is okay. Otherwise, some error or some flaw is there in my software. So this is also known as behavioral testing. This is also known as data driven testing, or this is also known as input output driven testing. So here what we do, give input to the system, get the output, compare the output with the specification. If it matches, then the system is fine, otherwise there is some error. So as you are not touching the code or what is happening inside the code, so that's the reason why this technique is called black box testing. So the black box testing attempts to uncover the following things such as incorrect functions, missing functions, performance errors, initialization and termination errors, external database access errors. So these are the things that we can go for uncovering once we are performing the black box testing. As compared to this, in white box testing, you just imagine the system or the software as a white box. So white box in the sense what is happening inside the code that we are interested here. So with some input to the system, now I am going to execute each and every line of my code. That means you see how this input is propagating through this code. So here I am interested for the inside structure of the code, what is happening inside the code, right? So that's the reason why this is called white box testing. The white box testing also called structural testing, clear box testing, open box testing, logic driven testing. So these are the synonyms that you can use alternatively in place of white box testing. So using white box testing methods, the software engineer can derive test cases that guarantee that all independent paths within a module have been exercised at least once, exercise all logical decisions on their true and false sides, execute all loops at their boundaries and within their operational bounds, exercise internal data structures to ensure their validity. So whatever the data structure that we are using in a program, so whether the validation checks are there in the program or not, that is the main concern of your white box testing. So if I am going to use one array, so here the underflow condition, the overflow condition, if similarly somebody is using stack, the stack overflow condition has been checked or not, right? So whatever the data structures, the data types you are using, so each and every data type they are having certain values, the minimum value and the maximum value that can be stored. So such kind of validation checking that has been put or not, that is the main concern of your white box testing. So the internal structure of the software is taken into account to derive the test cases. So for the generation of test cases, we need the internal structure of the program in white box testing. So we will explore it in more detail in the subsequent classes. So these are the main techniques for this black box testing, by using which it is going to help me for the generation of test cases such as boundary value analysis, equivalence class partitioning, decision table based testing, and cause effect graphs. So in this lecture we will go for discussing the boundary value analysis and the equivalence class partitioning, and the rest too that will be covered in the subsequent lectures. So in boundary value analysis, we select values on or close to boundaries, and all input values may have one of the following. So in the test case, we have to go for taking the minimum value and a value that is just above the minimum value, maximum value and a value which is just below the maximum value, and a nominal value. So nominal here in the sense this is the average value, which is neither too close to the minimum nor too close to the maximum. So you have to choose an average value between the minimum and the maximum value, and that is called the nominal value. So we will look for one example here. Suppose there is a program named as square which takes x as an input and it prints the square of x as output. So this program is going to calculate the square of the input value, that is x, given to the program, and suppose the range of x for the user is 1 to 100. So one way we can go for testing this program by providing input all the values from 1 to 100 one by one. That means you start running your program, give input 1, then 2, then 3, then 4, then 5, then 6. In the way you can go up to 100. That means you are going to execute this program 100 times. You are going to execute this program 100 times, right? So if this range extends to 1000, if this range extends to 10,000, so really it's not feasible to run the program 1000 times or 10,000 times by taking all the possible values of x. So here we can go for using this boundary value analysis, and we are going to find the minimum number of test cases so that I will ensure my program is fine or it is running without any error, right? So by using boundary value analysis technique, what we are going to do, we select values on or close to the boundaries, and the values are like one minimum, the minimum value, and just above the minimum value, the maximum value, just below the maximum value, and the average value, right? So these are the possible values for x that I can use for testing of my program, such as 1 is the minimum value, 100 is the maximum value, a value which is just above the minimum value, that is 2, and a value which is just below the maximum value, that is 99, and one average value which is the average of 1 and 100. So that is nothing but my 50. So this is the way, only 1, 2, 3, 4, 5. So these 5 values of x, if I am going to use to test my program, this is sufficient for me to test this program, right? So here we can say if n is the number of inputs, then by using this technique, for n plus 1 number of test cases can be selected to test the program, right? So one nominal value is selected which may represent all values which are neither close to boundary nor on the boundary. So that is the reason why we are going to take the nominal value or the average value. So if you look at the test cases here, so these are only the 5 test cases, like 1, 2, this is the average value 50, and this is the maximum value 100, and a value which is just below the maximum value, right? And this will be my possible expected outputs. We'll go for another example here. So here the program is, suppose, addition of 2 integers, and my program is going to take 2 input values x and y, and it gives the addition of x and y as my output, right? And the range of both input values are given like this: x is from 100 to 300 and y is from 200 to 400. And now if you go for using this boundary value analysis technique, so these are the possible values of x, right? So the minimum value is 100, a value just above the minimum value, that is 101, the maximum value is 300 here, and a value which is just below the maximum value, that is 299, and one average value which is 100 plus 300, that is 400 divided by 2, it is 200, right? And similarly for the value of y, I can say the minimum value is 200 and a value which is just above, that is 201, 400, 399, and one average value which is 200 plus 400 divided by 2, and it is 300. So these are the possible values of x and y by using boundary value analysis, and accordingly we can go for generating the test cases. Like, so test case 1, I am going to input the various values of x like 100, 101, 200, 299 and 300, and the average value of y. And similarly the average value of x and the possible values of y. Okay, so this is the way you go for generating the test cases. So if you look at here, so the average value of y and all possible values of x, this is 1, and similarly the average value of x and all possible values of y. So this is the way, if you look at, I am having total 10 number of test cases that I am going to generate. But if you look at here, the test case number 3 and test case number 8 both are same, so you can ignore a single one. So the 8th test case I am going to discard, and after discarding this, the total number of test cases will be 9. So again the formula is 4n plus 1. So if n is 2, that means the number of inputs are 2, x and y. So the number of possible test cases will be 9. And the next one extension of this boundary value analysis is robustness testing. Here what is happening, we go for selecting some invalid values also, and we are going to see how my program is responding. So hence here we go for adding two additional states, that is one value just below the minimum value, that is minimum value minus 1, and just above the maximum value, that is maximum value plus 1. So this extended form of boundary value analysis is known as robustness testing. And here, if n is the total number of inputs to the system, then by using the robustness testing, we will be having 6n plus 1 number of test cases that is going to be generated. Right? So we are going to use, so if you look at here, the all possible input values will be like this: the minimum value, a value just above the minimum value, a value just below the minimum value, a value just above the maximum value, a value just below the maximum value, and one average value. So two extra, if you look at here, the third and fourth, these are the two extra cases or extra values I am going to add here. One value is just below the minimum and one value is just above the maximum. So they represent exactly the invalid values, because previously whatever values we have taken all are valid inputs of x and y. But here we are talking about, along with the valid values, we are going to take some invalid values also, right? So if we go for the same program, the square program, so if you look at x here, the value is ranging from 1 to 100. So the minimum value is 1 and the maximum value is 100, right? And you see, we are going to add a value which is just above the minimum value, that is 2, a value just below the maximum, that is 99, and one average value which is 50. Along with this, we are going to add two new values. One is just below the minimum value, that is 0, and one is just above it, that is 101. So if we count the number of values, so 1, 2, 3, 4, 5, 6, 7. So as here n is 1, n is the number of input. So the total number of possible values by using the robustness testing is 6n plus 1. So 6 into 1 plus 1. So it is total 7. And similarly, for the same program addition, if you look at here, I am going to input two values like x and y, and the x is 100 to 300 and y value ranges from 200 to 400. And these are the possible values of x, right? So 100 is the minimum, just below 99, maximum is 300, just above 301, a value just below 299, a value just above the minimum, that is 101, and one average value here I am missing here, you can write here. So that is nothing but your 100 plus 300 divided by 2, that is 400 divided by 2, now it is 200, right? So this is the way you can go for choosing the y value also, and then you are going to create the test cases. So all the possible values of x, you see 99, 100, 101, 200, 299 and 300 and 301, and the average value of y, and similarly the average value of x and all the possible values of y. So this is the way you can go for giving the expected like this. So here all the possible values of x and the average value of y I am taking, and all the possible values of y, and I am going to take the average value of x, right? So this is the way you can go for generating the number of test cases. And if you look at here, the total number of test cases that you are going to generate is 13, right? So again, the formula is 6n plus 1. So n here is 2, 2 is the number of inputs. So 6 into 2 plus 1, so 12 plus 1, that is 13 number of test cases are going to be generated. Next we will go for the equivalence class partitioning technique. So in this technique, what we do, the entire input domain can be divided into at least two equivalence classes. So one containing all valid inputs and the other containing all invalid inputs, right? And here each equivalence class can further be subdivided into equivalence classes on which the program is required to behave differently. So this is the minimum classification. So one input domain which is going to contain the sets of all valid inputs, and another one is all the invalid inputs, right? So after creating this, according to your requirement, you may go for again subdivide the valid inputs or the invalid inputs into some possible further subclasses, right? So if you look at here, the same program, we are taking the square, and this program is going to take x as an input which is ranging from 1 to 100, and my program is going to print the square value of x, right? So if you look at here, I am going to divide the whole input range, this 1 to 100. So 1, I can say the x is lying between 1 to 100. So this is one class C1, right? So these are all valid inputs which ranges from 1 to 100. And similarly, I can go for creating another class, any invalid inputs where x is less than 1. So this is a set of values, or this class is going to contain a set of values which are less than 1. So less than 1 means 0, -1, -2, -3, -4, so on. And similarly, I can go for making another class of input values where I am saying the x is greater than 100. So what does it mean? Again, these are the invalid values of x where it is greater than 100. So the possible set of values may be 101, 102, 103, 104 and so on. So now from these three classes, to test your program, you can choose a particular value. So for example, I am saying if I am going to choose a value from class C1, suppose this is 20. So which is lying between 1 to 100. So this is the valid input to my program. And similarly, for the class C2, I am going to choose a value -5, which is less than 1. So this is an invalid input to my program. And similarly, from class C3, I am going to choose a value of x which is greater than 100. I am choosing 105. So that means whatever value you are choosing from a particular class, that value is going to be a representative for that class. So for that value, if your program behaves properly, then it believes that whatever value I am going to choose from that domain, my program is going to behave accordingly. So three test cases are generated here, such as test case 1, input value is 0, so this is expected output will be invalid input. Test case 2, I am going to choose 50, the value of x, so output will be 2500, a value that is chosen from class C1, and this is a value from class C2, and this is a value I am going to choose from class C3, suppose 101, and my expected program or my expected output from the program will be an invalid input. So these are the two techniques that is going to help us for the generation of test cases. Thank you.